Okay, so we're actually starting at slide 19 in the February 23rd lecture. And we're going to talk about interfaces in ArcObjects. You might have seen we haven't done much ArcObjects code yet. We will. You might have seen things like, rather than just saying map, it says IMap or I feature class. You'll see class names prefixed with the letter I. Those are interfaces. And they're a little tricky, but we'll go through them slowly, and you'll be interface experts after a couple of exercises. An interface is a logical grouping, and many programming languages don't expose interfaces to the developer. So you could potentially have a lot of experience with programming and not have come across interfaces. But in ArcObjects, we need to use them. So one way, whenever you see what looks like a class prefixed with an I, that's what's called an interface. So I document is an interface, and we work with interfaces to classes a lot in ArcObjects. As I wrote here, it's a logical grouping of properties and methods for a class. It's a way to group methods and properties on a similar purpose. And the reason, we'll get into that, is a particular class can be used in many different ways and can have many different properties. Interfaces are part of the COM model, component object model, which many programming languages adhere to. The COM model also allows us to access programs in a different language. As an example, ArcGIS is actually wrote in a different programming language called C++. But because ArcObjects is COM compliant, we can use C#. Or we can use VB.NET to program with ArcObjects. So interfaces are a way of grouping common uses of the class together to be more efficient. And we have plenty of examples about this tonight. But say, if you think of the class human, there's a lot of different roles a human plays in the course of a day. I mean, you have general properties and methods, height, weight, age, but you might be an employee, you're a student, you may be a parent. If you think about it, there's a lot of different things you do. And rather than having one class human with all these different possible things, we group the categories into these interfaces because every object in that class doesn't necessarily use all of the class. For example, one role a human plays is to be a parent. But not everybody is a parent. Many people don't have children. So why expose all those methods and properties related to being a parent to an object that isn't a parent? And hopefully and I know because I learned this too 16 years ago. It's too long. This is confusing when you first start thinking about it. I know it was because I was completely confused until I started getting into it. So if you have the class human, you apply different interfaces to the human based on the role the human is playing in your program. If it's a program about parenting, you would declare the variable using iParent, not human. If I'm giving out class grades, I don't care if you're a parent or not, but I might use the interface IUBStudent. But IUBStudent and iParent both apply to the same class, human, but they work in very different ways. I hope that helps. So if we go back to our birds that we looked at the very first day, this is a shrike. It's a songbird, but it's actually a predator. You can see the hookbeak there. It preys on small birds and mice. This is one thing. It's a shrike, but it can be accessed in a number of different ways. If we're talking about carnivorous songbirds, you could have an interface iShrike, and that interface would have properties only related to the shrike. A larder, this is kind of weird, the male shrike to impress the female bird catches mice and little birds and puts them on a thorny tree. Stacks them. I remember the first time I saw that in Take a Hike, I was kind of concerned about that. It's called a larder, like a shish kebab of mice or something like that. So the properties of building a larder only apply to the shrike in this way. But in addition to being a shrike, it's also a bird. It's also an animal. So we can look at this thing here 3 different ways. You can look at it as an animal. You can look at it as a bird, or specifically as a shrike. And so if you have this property larder, the thorn of dead mice, that's the only bird that does that. There's 10,000 other types of birds in the world that don't do that. Why would you waste space in your code having a core level property larder on just the class bird when 9,999 times out of 10,000 you're never going to use it? Does that make sense? So this kind of groups the properties in a more efficient way. So now the property larder only applies to the specific interface shrike, and we're not wasting computer memory in these situations where it's a different bird. So in arc objects, the way we handle that, you actually declare the variable using the interface, not the class. So when we looked at instantial variables a month ago now, we say string, my string equals Greg, double or integer, temperature equals -4, etc. Here though, it's a little different. We declare the variable using the interface, not the class. So instead of saying shrike, my bird, it's I shrike, my bird. But then we set, if we're creating a new object, and we'll talk about that type of class probably later tonight, you're still creating the object as a type in a class. So it's new shrike, but the variable is declared with the interface, I shrike. So we're saying here, give me an object that's a new shrike, and I'm going to access its properties on the I shrike interface. So create a new shrike, and this is the set of properties I'm interested in, not these. Make just a little sense? And so for example here, hook bill was one of the properties on the shrike, I shrike. Here, I've declared a variable using I bird. So by saying that, I'm saying give me, but it's still a new shrike. Give me a shrike, and I'm going to use these properties and methods. Or finally, I animal kingdom, my bird. We're still setting it to a new shrike, but we're going to use the properties and methods on the interface I animal. That should say I animal, I guess not I animal kingdom. It doesn't matter, it's just an example. So the takeaway point is that one class has these different subviews into it called interfaces that are a subset of its properties and methods. And this is done as a way to make your code more efficient and not waste a lot of computer memory exposing every possible property and method a class could ever need. Does that make sense? In another example, these might be out of date, we'll look at football. In football, you have an offensive player, a tight end. The tight end feels, depending on the play that's called, the tight end has different roles. But it's the same person. It's just that same person fills a different role in different kinds of plays. Sometimes they may throw the ball to the tight end. So he's a receiver. The tight end catches the ball. In other situations, it might be a running play where the tight end is assigned to block. You block for someone that's running. And then even more generically, the tight end is a player, just like every other player on the field. So here's 3 different interfaces you could use for a tight end in football. So the class would be tight end, but you're using the tight end in different situations. And so you would declare the interface using the same tight end object, but the interface is different depending on how you use the class in your code. So there may be an interface I receiver, and there's properties and methods associated with that action in football. The method catch, or how sure-handed is he? not most of the bills aren't super there. Yard, what is this? And then he may have reception statistics, average yards after catch, number of touchdowns, et cetera, et cetera. In this case, there could be an interface I blocker that represents the action of blocking for a running back. But again, the point is it's the same person. On one play, you might throw a pass to the tight end. On the very next play, the same guy might be blocking. And more generically, it's an NFL player. You could even have a fourth one on here, presumably it's a human. So the tight end also would be able to be honored by the iHuman interface, the same interface as you. So can you see this? Maybe that also illustrates the silliness of having every property and method possible. So if there's a specific property to an NFL tight end, do you want that? Do we want to say, we wouldn't say what's Willard's yards after the catch in the NFL. At least as far as I know, he hasn't played, unless there's something you're not telling me, hasn't played in the NFL. Yeah. The Bills might be looking for someone. They're getting good again. I won't be able to joke with that anymore. It took 30 years. So that's a waste of computer memory to have. If I'm using the class human in conjunction to Willard, it's a waste of computer memory to have all these NFL properties in here that don't apply. But if he were an NFL player, they would apply, but other things might not. I mean, there may be properties and methods a human as a UB student. Your GPA, things like that, only apply if you're a B student. So an interface is a subset of property and methods on the class. I hope that helps. And here's an example of, and this is here's an example used a lot. We'll talk relatively soon, maybe just even a couple slides from now, about what all these symbols mean. So this is a screenshot of the class map out of the ArcObjects developer help. Something that we'll be looking at a lot. So map is the class. A map represents a data frame in ArcGIS. In the map, just like human would work with a bunch of different interfaces, I UB student, I tight end, I receiver, all these, I parent, all these things. These are the interfaces that work with the map. So here's the analogy to the GIS world. There's usually a default interface with the same name, but map and IMAP. But we have here iActiveView is the second most used one. I don't see it. Oh, it's down here. So iActiveView and IMAP are two different interfaces that work with the class map. Just like iReceiver, iBlocker, iRun. I mean, I suppose you could hand the ball off to the tight end too. All those interfaces work with the tight end. All of these interfaces work with a map. A map also is a graphics container. That's one we will use, and we wouldn't have time to go through these. There's some, I think I have a slide on this. There's some ridiculous amount of interfaces in classes, like 18,000 or something like that. There's no way you would teach them all in one course. I don't know them to teach them all to you. I bet no one at Esri knows all of them. And a good help system means you don't have to. We will touch on some key ones. The one here is graphics container. If you think a data frame also has a collection of graphics that you may have added to it, text and shapes that aren't necessarily in a shapefile or a layer, you can access that by declaring a variable on the map using iGraphics container instead of IMAP. And there's even an interface called iGraphics container select to return whether any graphics are currently selected. So those are two of many different interfaces that work with the base class map. And we haven't gotten to the point where I would expect anyone to understand exactly what I'm talking about in details, but in the high level, hopefully you can see what's going on here. Where there's different specific interfaces that serve a specific function to the map class or data frame class. And many of the details we'll get into going forward. One term polymorphism. I might ask that on the quiz. Those are the type questions that I would ask on the quiz. What is polymorphism? And you like go in the notes and find general things like that. Polymorphism is many classes supporting the same interface. This happens all the time in ARC objects. So you have an interface I layer, but there's a lot of different specific types of classes that can inherit from into I layer. Your feature layer is vector-based GIS data, raster layer for grids, CAD feature layer if you're adding AutoCAD data in. That's an example of polymorphism. You could have that in football too, because there may be, well, there's an interface I receiver. There's multiple different types of classes or different types of positions that can catch the ball. I mean, a wide receiver is the most likely candidate to make a catch, but the tight end can too. So that's polymorphism. Both the wide receiver and the tight end could be I receiver. You could even have a flea flicker, and the quarterback could be a receiver. So that's three different classes of player that could all support the I receiver interface. So I think the concept of polymorphism also works well in the football example, if that makes sense. So, what happens when, and you'll run into this a lot, say on the bird, you need more, invariably this is great, what a great way to make all this efficient. It really makes things easy and compacted, until you need something here and there, which will happen. Then what? You're building a report on the tight end, and you want to know his yards after catch. You also want to know his years experience. And now suddenly you need both interfaces. How do we do that? There's a couple different ways we do that. The term would be a QI or a cast. QI stands for query interface. Frankly, more in C# I hear it referred to as casting. So you're casting the variable that was built in one interface into another. You're actually creating a second interface. No, you're not. You're creating a second object of the same class using a different interface. So one example that I think we will use this exact example. You have in GIS a point, zero-dimensional object representing one spot. So on the first line here, I've declared a variable called myPoint, and I've used the interface iPoint. And I've said it's a new object in the point class. I'm preparing to add a point to a map. You'll certainly do that in Lab 7. I think we'll do it even sooner. The Lab 7 is something that comes to mind. You'll do it in Lab 4 with the identify also. This will come in handy in Lab 4 and Lab 7. So we have our myPoint object using iPoint. But sometimes there's a more generic interface that you could use also, and in this case that's one of these types. There's a more generic interface called iGeometry. iPoint has methods and properties specific to a point type object. iGeometry is more generic. It could be any type of vector geometry. It could be a line, point, polygon, etc. So you have a specific interface and a more general interface. And sometimes you have to cast between those. The example here would be these are specific, like iReceiver is a specific interface where INFL player is more generalized. So iReceiver is a lot like the iPoint, INFL player is like the iGeometry. Or same thing even here where you have a specific like iShrike and a general interface iBird. You save the more generic things for the iBirds, the INFL player, or iGeometry. So to cast, what we do is we create a second variable. I called it myGeo there. We create the second variable with the second interface that we have an interest in. And then on the right-hand side, we put, this seems so redundant, and it is. So that's the nomenclature. You put the interface you're casting to in parentheses, and immediately following that, the original object. So interface 1, object 1 is set. Interface 2, object 2 equals object 1 with interface 1 in parentheses. And it is redundant because you'll always repeat the interface name twice, but that's just the way it is. And I think I did some rehab on this slide, so it looks funny, but there's nothing in between there. It's iGeometry, my point, the original. So now we have two different variables pointed to the same object. So my point and my geom both refer, that could be hard for people to visualize too, it was for me. Both of those variables point to the same object. An example would be the player again, or one of you, this is a weird example, maybe it works. To your parents, you're their child. To you be, you're sophomore, in the geography department, etc. But it's still you. You have two very different ways of looking at you, the same person. You might have two different variables to define you. One as a child, two as a UB student. But when it comes down to it, you're the same person. You're just being looked at in two completely different roles. So here, the same point in a similar way is being looked at with the two variables. An error, and I've messed this up enough times. You're assuming, this code assumes that iGeometry and iPoint are castable. Not all interfaces can be cast to all things. And if this item in parentheses isn't castable to iPoint, you'll cause a program error. Like for example here, I didn't take the example far enough, but the tight end, there are only certain interfaces that work with tight end. I mean, there could be a lot of them. Even IUB student might work. I mean, it might be a UB Bulls player who is a tight end and also a UB student at the same time. But iShrike doesn't work with tight end. A tight end can never be a Shrike. Tight end could be a UB student. It could be all these different things: receiver, blocker, runner. But there are interfaces and classes that just don't go together. And so when you're casting, you need to make sure, using the help, we'll learn about that the two interfaces do go together, or you'll cause an error. So one way, and I'd be lying if I said I always did this, but I should, even though I don't do as I say, not as I do. Here's some defensive code to test for that. You can use the keyword is on the original object. So here, if my point is iGeometry, that will return true if my point can be cast to iGeometry. And then you can proceed and make your cast. Since this is relatively static in code, this isn't always necessary. But here's how you can test beforehand if you need to, whether an object is castable, whether this object is castable to that interface. Any questions? You can also use the keyword as. I think it's just a preference. I tend to do the former. I don't think there's one is better than another. There is a difference, which I'll mention in just a second. So in this slightly different example, so we have our first point being declared. Whether it's iGeometry, my geometry, but instead of the parentheses, you set it equal to the original class as iGeometry. It's also more like this. If this were a VB class, that's how you would do it in VB. So it's a little more similar to the VB syntax. It doesn't matter too much. The difference is, the biggest difference is before, as I said, if I'm trying to cast the tight end to the Shrike, I'm going to get a program error. Using as, it doesn't cause an error, it'll give you null, which could be equally as bad. But so there's a slight difference between the two. So any questions? I guess I wasn't kidding. We'll start in a second with using ArcGIS Developer Help. we'll spend a good deal. This will involve, we'll look at this from several different aspects. We'll look at using the web tool that's loaded when you install the developer SDK to look up things. We'll also spend some time talking about the different types of classes, because that'll play right into using the help. And we will look at object model diagrams also. So to get to the .NET help, first of all, for those of you that have your own system, when you still have the disk in there? To get the developer help, there's something you need to do. You need to install it. Well, maybe I can just, I don't know, to show you. The developer SDK, for those of you that tried to set this up on your machine, you install ArcGIS Desktop using these disks. They have a few boards you can see. But then we would have done this anyway because you have to do that to work for Visual Studio. Remember I mentioned last week you needed to go to the ArcObjects.net SDK installation on the disk and also install that after you install Visual Studio? Well, that process also installs the developer help. I was going to say make sure you do this so you get that, but if you're working in Visual Studio, you must have already installed it. So just to switch back, I have Windows 8, it's a little different. But to show you how to get to it on Windows 7 on a jail machine. Maybe I can't. It was up before. Oh, there we go. You go to the Start menu, ArcGIS. It's HDMI. ArcGIS, and there's ArcGIS Developer Help. And what we're interested in is this ArcObjects Help for .NET Visual Studio 2010. And that opens in a web browser. It's actually installed locally, so you don't have to use the internet. And we'll spend some time looking at what you can do in this help. That's how you would get to it on these systems. Let me hop back. And the slide kind of shows this screenshot too. So when the help first opens, we have general topics in the upper left. Your introduction, ArcGIS help for .NET developers, and so on. So a lot of this is general light reading, and then there's very specific things that we'll use as well. The ArcObjects programmer gets a lot of information from this link here, ArcObjects reference. The ArcObjects reference contains links on all the libraries available. So this is something you'll work with frequently when you're developing. Remember we talked a little bit, we haven't gotten into this too much, where all the ArcObjects are grouped into different libraries depending on function. There's a 3D Analyst library, a Cardinal library for symbology, and so on. For each one of these libraries, you can click on that hyperlink and see a list of classes in that library and then look up more specific information about them. So here, it changed a little. The only difference is you can, that's actually cool, it has more help on .NET itself, which I like. Under ArcObject SDK, now this is 10.3, and you have 10.2 here. The ArcObjects reference is right there. a criticism I have about this is, to me, it's one of those things that they assume you already know. Like if I want to find out, I want to find out about our iFeature layer. I don't remember much about it. Well, you kind of have to know which one to click on first. But just to show you, I think there's a slide that does this, but if you click on a library, it gives you, well, first it gives you what tools it works in. The Cardo library is very generic. It works on desktop products like we're learning, but it also works on ArcGIS Server and ArcGIS Engine. It may depend on other libraries. And then it gives a very general overview of what the library does. The creating and displaying maps, map and page layouts, and it has some nice diagrams of all the different classes and how they relate to each other. Often what you're looking for is the object model diagram, which then we'll talk about these diagrams shortly. Oops. Or the contents. The contents has all of the different interfaces. So these are all the interfaces available just in the Cardo library. Look how many there are. Maybe you can see why learning the help is so important to me. Nobody knows what those all are. No one at ESRI could possibly know all those. There's different teams of people writing specific code. That's just in one library, and there's like 50 libraries. Not meant to discourage you, just meant to, and 95% of you never use, but meant to illustrate that sometimes our time is better spent learning how to look this up rather than trying to memorize a whole bunch of stuff. So there's iFeature layer, which represents a feature vector layer in ArcMap. And I can click on that and get its properties and members. I'm going to come back to this because we do get to that in a few minutes. One web address, and I think I have a slide on this, that's useful, is resources.arcgis.com /en/help/objects-net. Let me see if you can get to that without having to memorize that. They like to change their website around. Well, that's how you get to that. Not that hopefully you'll remember. In general, a good resource is resources.arcgis.com. Then communities, arcobjects.net would get you to the web version of what's installed. You have this installed on your desktop and you can get to it using the manner I just showed you, but this is a way to get to the similar set of information online. Maybe you're somewhere where you want to look something up and it's not installed locally. This is how you get to it online. But sometimes, as I said, a criticism that I have sometimes is you kind of have to know what you're looking for before you're looking for it. One way around that is often I'm just searching. You'll see up here, I'll show it in a second, there's a search bar. Sometimes, rather than trying to find what library something, you just search for it here and you get the results. So I type up here, iFeature layer, hit enter, and then you get results. Again, this is going to look slightly different than your results in 10.2. Then you see iFeature layer interface. That's a shortcut to get to something without having to go searching for it. We get to that same spot. This is the interface. It tells you up there what library it's in. esri.arcgis.cardo. sometimes they replace it. A rule of COM programming is you can't ever change a property or method or an interface. So what they do is they add new ones. So there's actually an iFeature layer 2. It's the sequel we probably should be using. I never do. It's a feature layer, has these properties and methods. The feature layer is a class representing a vector data set as a layer in a table of contents, like a shapefile or geodatabase feature class. So you can see things that you would recognize, like its minimum, maximum scale, its projections, and so on. And so this is a review from day one. The interface lists its properties and methods, members. That's weird. Inherited interfaces. Those are parent interfaces whose members are also applicable. So in other words, iFeature layer has a parent I layer. And in that case, you can use the properties and members of I layer because it's the parent. It's like someone's able to refer to you as with your last name because you share that with your parents. Co-classes. These are other classes that can be used with this interface. Some of this is the discussion we'll have shortly, so that some of this we haven't covered yet. And then any other relevant information. And as with most websites, any blue text is hyperlinked. So I see on iFeature layer, I see, minimum scale. I want to find out more about that. I can click on it. And there's a page about that specific property. Bless you. So minimum scale is the lowest scale at which a layer will display. You can set that in your layer properties too in ArcMap. You've probably done that before. And then it gives in a couple different formats. It's funny, all in C++. I'm used to seeing here a C# and then VB.NET example. They're all three of them are C++. But this describes further about this property. Oops. So here, there's just a screenshot of it. Well, that's in the screenshot at the maximum scale. It doesn't show VB.NET, but this is what it does. I don't know why it didn't. I'm used to seeing different parameters in .NET, C# and C++. Are there any questions? That's the end of the February 23rd. Part. No, had we done that last week, you would just pick up with the same topic tonight, which is why I decided to just roll it into one lecture. Are there any questions before we move forward? Okay, so we'll go. Now we're on the March 2nd lecture. Slide 1. How many? There's not that many. ArcObjects makes use highly of what we call object model diagrams, or OMDs. So object model diagrams are a graphical representation showing about how all the classes and interfaces and whatnot relate to each other. The screenshot I showed you of map with the different interfaces next to it, that was a capture from the object model diagram. This is the location. Not that this helps you, because you probably can't get to that in the lab. But if you install 10.2 on a machine where you have privileges, that's where the object model diagrams will be installed. To get around that, and I noticed that they're 10.1. I don't think there's much difference. On the M drive, under M Geography GEO555, I have a folder called Developer Kit 10.1. It's a little outdated, but I bet we wouldn't find a difference. 10.1 and 10.2 are very similar. In fact, in this developer kit, I provide access to everything that's installed with the developer kit in the developer kit folder, because the jail is unique where you can't get to the proper folder. So it's hidden. So you can get to all of that in this folder, including diagrams. So this diagrams folder gives you all of the classes diagrams. So if we were interested in the Cardo class, or the Cardo library, it's Cardo object-model.pdf. And so just in Cardo, there's 12 pages. That's actually the screenshot I took for the slide. It's 12 pages of this, and that's just that one PDF. So you might visualize now how many classes there are. It's way over time, if you ask me. So that's the location I have for you if you're in the lab and you want to look at them, because you won't be able to get to the proper location. You'll see on my machine, where I do have access to my E&E laptop, I've got Developer Kit 10.3. It's a little different, but same deal. Diagrams. And there's all my PDFs. There's 71 diagrams, a lot of them having 10 or more pages. But again, 98% of them you may never use. Some told me this is the largest common implementation of any software in the world. I don't know if that's a good thing or a bad thing. You can also, and I think I showed this first, you can get to them. This doesn't work on every machine for some reason, depending on how it's installed. In the help, I showed you this additional library information. You can click there to get it'll bring up the PDF if you can find it. So it's another way to get to the PDF. Each diagram set is a PDF that displays for all the classes in that library how the class is related to interfaces, members, and other relations. So sometimes we have to cross libraries. So this is a screenshot of the ArcMap user interface library. Another commonly used one. MX document is a class you'll use in just about every program you write that represents an MXD. But data frames are in Cardo. So you can see a data frame is related to an MX document, but it's in a different library. So we have all these bubbles that link to even different PDFs. It can get kind of confusing. We'll talk about what we'll do is now spend a fair amount of time defining all this specific nomenclature and what it means. And before we do, or to start in that, we have here on every PDF there's a class diagram key. Okay. So we have three different types of classes: an abstract class, a regular class, and a co-class. We'll talk in just a second about those. We also have in this key a couple other things. We define interfaces on a class. So for every class it shows what interfaces can you use with that class. If I have tight end, can I use iShrike? No. Can I use iReceiver? Yes. Those type of questions are on the diagram. So in this generic example, this class can be used with interface D and interface B. The interfaces that are applicable are shown with this lollipop, or whatever you want to call it, that sticks out to the left of the class. And you have inbound interfaces and outbound interfaces. We'll exclusively talk about inbound. Outbound interfaces let you program your own custom events, mostly on like a data frame. And It's an advanced level beyond which we'll do here. But be aware of when you see a filled-in lollipop, that's what that means. Most of the lollipops, there may be a more technical word than that, are inbound, and they're a hollow circle. And then within the class, we see its properties and methods. Methods are easier. They're drawn with a little arrow to point to the left. If you remember from day one, a method is an action that a class can take. You know, bird.fly is a method of bird. Clear selection is a method of map, and so on. Properties, there's a couple of different ways we can look at properties. And I'll go to the next slide because I think well, before we do that, another thing we'll talk about are enumerations. Enumerations are where you are setting a property or retrieving a property and there's a set number of possibilities. So for example, let's say you're issuing a command to create a new vector shapefile. One of the things you set is the type of shapes. Well, there's only a set number of possibilities, you know, point, line, polygon. So you do that with something called an enumeration, where there's only a set possible number of values from the method. And the different type of properties, you can have a read-only property, a write-only property, read-write, and then put by reference. We'll talk about the difference that means in a second too. And here we are now. So here's the four different ways in which we denote a property of a class on the diagram. The first one, and this is maybe like a dumbbell for lifting weights. The first one here has a line and the dumbbell on the left is there only. So it's only got the square on the left and it's filled in. That's called a property get. And that's a fancy way of saying that that property is read-only. On a layout, on page layout, I can, using this interface, I can get the page size, but I can't change it. The property page is only read. I can use ArcObjects to get the value, but I can't change the value using this method. I can't change the zoom % using this method. It's read only. I can only read it. The dumbbell just on the right is property put. That's rarer. That's a write-only property, which you don't see that often. I can change the value of that property, but I can't see what it is. That's kind of weird, because that's unusual. The only one I can think of off the top of my head will work with an interface called iFieldEdit, which is used for creating a new field in a shapefile. iFieldEdit is write only. You can use it to assign a new field name, but you can't use it to read an existing field name. But the property put is somewhat unusual in ArcObjects. Write only. The third one is fairly common. Read-write. And you'll see two dumbbells. It's a full dumbbell, I guess you could say. When you see both filled in squares, you can read the value, but you could also change it. It's not pictured here, but on feature layer, there's that minimum scale property that I brought up a couple minutes ago. That's read-write. I can use the property to determine the feature layer's existing minimum scale, but I could also use the property to change the minimum scale using code. So that's a read-write value. And then finally, put by reference. With put by reference, you can assign the value, but it's another object. So we talked about intrinsic variables a month ago or so. Things like 48 numbers are intrinsic variables, names, strings, and numbers. Those are true, false. Those would be filled in circle. Put by reference means instead of assigning an intrinsic variable, you're assigning another object. So if I'm not going to bring up the original, but in the first class I had a slide on a bird, and one of the bird's properties is length. What is the length of the bird from head to tail? That's an intrinsic property, so it would be filled in because the answer is a number of 15 inches or whatever. Another property a bird might have is wing. I need to get to the bird's wing. The wing is not an intrinsic property, it's another object. If the example is you have a height, that's an intrinsic property about you. You also have an arm. That's not intrinsic, it would be an assignment by reference. Hopefully that explains the difference for you. And the reference properties would have the hollow box like you see there. The general rule of thumb would be if you can write down the property, it's intrinsic. Like you could write down the number 63 or true or your name, but you can't write down your arm. It's a non-intrinsic, it's another object. And then as I said before, the methods are easier. It's just an arrow pointing to the left. So here are methods on the page layout. Like zoom to whole. There's a method on a page layout that zooms out the page layout to show the whole thing on the screen. It's an action, and it's denoted with a left pointing arrow. Any questions on that? These are the type of questions on the quiz. I'll say, how many put by reference properties does page layout have? And it would be 1. Questions like that where you would go into these diagrams or go into the help to get the answer. Those are the kind of things I'll ask. A couple of minutes ago I talked about these 3 different types of classes. We'll discuss that now. The first one is an abstract class, and on an object model diagram, the box of an abstract class will be empty and not filled in, and the title will be in italics. See up there where abstract class is italicized? Abstract classes are just that. They're abstract. They can't be used to create objects. Abstract classes are usually a general category of objects. So you'll see here, and they always show an open triangle below them, which is part of this family tree. The open triangle below them means that these objects down here inherit from the abstract object. And a good example of abstract object is layer. You can't create just a layer. I mean, it's a feature layer, it's a raster layer, it's one of these things. So it's an abstract class. An example of an abstract class I use for the animal kingdom is mammal. Do you ever have just a mammal? I mean, a mammal is a class of animal, but there isn't something walking out there that's just mammal. It's a human, or it's a dog, or a cat, or a fox. You don't have just a generic mammal running around outside. So a mammal is an abstract class in the animal kingdom, and you would have specific classes inheriting from that, like human, cat, dog, fox, etc. So that's an abstract class. So we can use abstract classes in code, but we can't declare an object with them. So here's a better look at this layer abstract class. These are so all the different specific classes that represent specific types of layers. So you could have a composite layer, a rest layer, group layer, base map layer. All these are just different specific types of map layers that you can create. But there's no such thing as just a layer. Just like there's no such thing as just a mammal. You could say even that class bird was abstract. You don't have just a bird. Every bird is categorized by a specific species, shrike, eagle, goose, so on. So those generic types of classes that many different specific categories inherit from are abstract classes. The next type of class, and the difference between these next two is a little bit more ambiguous. A regular or instantiable class do contain real objects. It's not like the abstract. But you can't create a new object from them. They have to come with another type of object. So an example in GIS, an edit selection. An edit selection is created when you have an edit session open and you select some features to edit. You can't just create an edit selection from scratch. You have to use iEditor to retrieve the edit selection. So it's a regular class that you need to use another class to create from. So if a class is regular, and it'll be an empty, not filled in box, but not italicized title, you must use another type of object to produce the class. Many objects fall into this category called co-class. The third category does contain a real object, just like a regular class, but you can use code to create a brand new. I used that new keyword a couple slides ago. So you can, if the co-class is filled in gray, if the class is a co-class, you can use code to create a brand new object of that class in code. Unlike the regular class where you can only use a regular class to retrieve an existing object. If number of seats in the course is not editable by me, that'd be like a regular class. If the course is capped at 20 students, I can retrieve the 20. I could retrieve the information about the 20 of you in the class, but I can't create another seat, or I can't pull in a 21st student if it's a regular class. If I did have that ability, which I don't think other people do, I don't. It would be a co-class where I could retrieve information about the 20 students, but if I had the power to, if someone emails me, asks to take the course and it's full, if it's a co-class, I could create another seat in the class using code and then populate the seat with the 21st student. I hope that sort of makes sense. So example here is a feature layer. You can create a brand new feature layer in code. You could have a piece of code that creates a new layer, adds it to your map, and asks the user to edit it. Because feature layer is a co-class. I never counted them. I think most classes fall into this category. There's many classes in which you can create a new object. Oh, it's a point. I can create a new point to do something with. Use it to identify. In Lab 7, you'll create points where user clicks. Point is a co-class. You're allowed to create a new point. The object model, the OMG, do not list every possible property and method. There's just not enough space. There's enough pages already. There's probably close to 1,000 pages, and that's more than enough. So what they do is have these, they call them lollipops. Right under the class, it lists what they're thinking are the most commonly used interfaces. So for a raster layer, iRaster layer is the most commonly used interface. iGeoReference is another commonly used interface with raster layer, as is iLayer position. But raster layer also can be used with all these other interfaces. So rather than try to list all of them under raster layer, they use these lollipops. And then you can look in help for more info. So I could say, if I want to use iIdentify with raster layer, you'll use it with a vector layer in lab 4. I can see here, oh shoot, I don't have the properties and methods, but at least I know that raster layer is workable with iIdentify. So I'll go look up the help for iIdentify. So that's a space-saving measure, and they're indicated, like I said, with these lollipops. Any questions? We're now going to talk about some of these lines and other things on the diagram that indicate how classes relate to each other. I touched upon this one already, but you'll see an open triangle. That's called inheritance, or is a type of. I really should have the triangle there. But an owl is a type of bird. So I should have the bird on top. I'm not sure why I didn't draw it that way. With an owl below it, with an arrow with an open triangle pointing up to bird, because an owl is a specific category of a bird. In the GIS example to the right, a symbol is an abstract class. You don't just create a symbol. There's specific types of symbols. A specific type of symbol is a line symbol, and the line symbol inherits from symbol. Line symbol is actually also abstract. If it was depicted lower, there's specific types of symbols: simple line symbol, cartographic line symbol, hash line symbol, and so on. So in this case, the class symbol is actually a grandparent, not a parent. So inheritance is something you'll see a lot, especially in relation to abstract classes. In the interface under the class will also tell you its parent. So there, that's a little hard to read. For iGroup layer, it inherits from iLayer. So it'll say iGroup layer : iLayer. Just like, remember in C# we did this, we built classes, and you saw, your add-in was or your specific control was a subclass of control. Or I made the example honor student, and then it said honor student : student. It's a similar setup to that. So here we see group layer is a child of layer. If you see it starts to get beyond what we need for this course. If you see unknown is like the origins of the universe or something like that. When you get to unknown, you're at the top level, like the all-knowing being or something. So iLayer inherits from unknown. That means that there's not anyone above iLayer, that you've reached the top of the organizational chart or the family tree. All interfaces and classes have to eventually work their way up to unknown. And this lineage does through layer. It's the top level. This nomenclature kind of has to do with putting objects by reference. Composition is indicated with a diamond, or it is made of, is the English description. So one object is container of another object. So an example, a bird has 2 wings. The objects go together. You can't have a bird without a wing. Things you could, if it, barring some accident, but the definition of a bird is to have wings. Conversely, you can't have a wing without a bird. You don't see wings in nature that just fly around without a body. You don't see birds flying around without a wing. So there's a composition relationship between them. The two objects, classes, rely on each other. So in this ArcObjects diagram, you have a legend. The legend defines how your symbols are drawn in the table of contents. There's another class called legend format that defines the specific patches that are used, whether it's a oval for a patch or a rectangle or an irregular shape for a water body. You can't have that without a legend because those go along with the... Before you create a legend on your layout, there's no legend format because there's no patches to go with. So those two classes go together. A legend has to have a legend layout too, so you see them with diamond there. You can sometimes even, this doesn't show it, does it? No. You'll see a number. Sometimes not only is there a relationship, but there's a definition of how many. In this example, not only do we know that a bird contains two wings, or not only do we know that a bird contains wings, but we know that it's a set number, 2. Like the human and arm example before, there's a set number of 2 arms. That's not true in every case. And if there's not a set number, you might see an asterisk next to the relationship. An example I use that may seem odd, think of birds and a feather. There isn't necessarily a defined number of feathers that have to go on a bird, but there is a defined number of wings too. Or on a person, hair. Every person probably has a different number of hairs. So that would be a less defined relationship, and you'd see an asterisk on the model diagram instead of a number. Any questions? And then creation. In creation, the first object is used to create the second object. One object precedes the other, and then begs which came first, the chicken or the egg. It's good. Well, I'm telling you the answer. The bird came first. For purposes of this discussion, we've ended that age-old debate. There was a bird before there was an egg, I guess. So here, on our diagram, we've solved that riddle. The bird creates an egg. That's indicated on the diagram with a dashed arrow. Like you see here, the bird creates an egg. On the GIS example, this is one we'll work with in, maybe lab 2. A workspace factory. This is another, there's a lot of weird things about ArcObjects, and to me this is one of them. A workspace is a location of GIS data. It might be a folder where there's shapefiles, or it could be a geodatabase. You don't just access that location, you build it using something called a workspace factory. So the workspace factory creates a workspace that you can use to read GIS data in those locations. You can't get to the workspace without using a factory. So here's the dashed line. The workspace factory creates the workspace. So just like my bird and egg example there's the dashed line. And then in the simplest example, I should say the loosest example, 2 classes can have an association. They do not require each other. The bird and the wing require each other. The bird and the tree have an association. The bird may build a nest in a tree. It may roost or sleep in the tree or perch in it. But they do not require each other to exist. I could cut down eventually it wouldn't be good for them. I could cut down all the trees. It doesn't make the birds disappear. Conversely, if I killed all the birds, the trees don't vanish. They have more of a loose association with each other, and that's indicated on the diagram with just a solid line. In the example here, I have a GIS example. It's CAD layer and CAD annotation layer. A CAD layer is data in a program like AutoCAD or MicroStation. A CAD annotation layer is specific to text layers in a CAD program, where people might label street names or building names or something like that. You could have both or one only. You could have a CAD layer with just annotation in it, so it doesn't require a CAD layer. You could have a CAD layer with just lines in it, so it doesn't require this. Or you could have both. It's just an association. I think we'll look at 2 more slides, we'll take a break. It's kind of the stopping point. And then as we saw earlier, there's many, when I count 71 different posters, often with multiple pages. You might have a relationship between 2 objects on different classes or different posters. So that's handled with these bubbles. So here's a composition relationship. You need an MXD to have a style gallery, but style gallery is in a different class on a different poster. So the relationship is started, and then there's an oval that tells the user to go look at style gallery on the styles diagram. So that's what those bubbles tell us: the name of the class, style gallery, and then the name of the name of the class or the name of the poster to go look for style gallery on. Does that make sense? And then finally, I mentioned this early on, enumerations are where there's specific values acceptable only for a parameter. And they can, you can look in the help, you can represent them with a number or with an enumeration spelled out like we see here. So one example I had given is if you're creating a new shapefile, you need to indicate whether it's a point, line, or polygon. That would be done with an enumeration. In this example here, we're building a selection. You know how you use select by attributes in the selection menu? That's the select features method in ArcObjects. And then it asks for the selection result enumeration. And this corresponds with the choices you would make in the select by attributes menu. Are you creating a new selection? If you are, you would type Esri selection result new. Are you adding to an existing? Then you would type Esri select result add or the number 1. That's an enumeration. You use enumerations quite a bit. That's the end of the help section. I said that's where what we've talked about over the last half hour to an hour is what the quiz part 2 will be on. We will start up now talking about really getting into programming ArcObjects in the 2 of the top level classes, applications, and documents. But let's take a quick break before we get into that.